let's look at finding the vertical, horizontal, slant asymptote. So let's start with the vertical asymptote. To find your vertical asymptote, you first have to make sure if your function factors, you need to factor it to make sure nothing cancels, or if something cancels, it's going to create something different. So as you can see, the top seems like it might factor, so using the AC method, it factors into x plus 6 times x minus 4 over x plus 6. We have x plus 6 on top and bottom, so this is actually going to cancel out, and it's going to give us x minus 4. In this case, if your factor cancels, if one of your factor cancels, it's going to create a hole in your picture. So when you graph it, instead of having an asymptote, you're going to have a hole. So we're going to have a hole at the factor that cancel out. So at x plus 6, so if you solve for x, at the value of x equals negative 6, you're going to have a hole. Once you simplify, there is no denominator anymore, so you don't have to worry about any vertical asymptotes. So we have a hole, but we have no vertical asymptotes. Your horizontal asymptotes is simply based on the degree of your top and your bottom. So when you look at the top has a degree of 2, and the bottom has a degree of, the highest power on x is 1. So there's 3 rules. In this case, we're dealing with the degree on top is bigger than the degree on the bottom. So when your degree on top is bigger than the degree on the bottom, we say we have no horizontal asymptotes. So to find horizontal asymptotes, you're just dealing with looking at the degrees of your top and bottom. So for slant asymptotes, this is only occurring in special cases. It only occurs when your degree on top, when the power on top is exactly 1 more than the degree on the bottom. As you can see, our degree on the bottom is 1, our degree on top is 2, so it's exactly 1 more than the degree on the bottom, so you do have to test for slant asymptote. For slant asymptotes, you must apply division. In this case, because we're dealing with x plus 6, we can apply synthetic division. So I'm going to set up my synthetic division. So I have plus 6, so the number that's going to go, remember to swap your signs, so it's going to be negative 6. Then we take the coefficients, we only take the coefficients, and we apply synthetic division. Bring the first number down. Then you take your number and multiply it by your number in the box. So negative 1 times negative 6 is negative 6. That's what comes up here. And we add. When you're doing synthetic division, you add. 2 plus negative 6, we end up with negative 4. Then we have 6 times 4. We have negative 6 times negative 4. So we end up with a positive 24. And they are going to add up to 0. The last number of your synthetic division always represents your remainder. But when you're looking for slant asymptotes, you don't care about the remainder. Whether you have a remainder or not, you don't care. You simply write, it's going to be the equation y equals your quotient. So in this case, our quotient is simply going to be, we have to bring the power down by 1, so we start with x instead of x squared. So we have 1x minus 4. So our slant asymptote is going to be the equation y equals x minus 4. So those are the steps of finding all 3 different asymptotes. Now let's look at this function. F of x equals x plus 1 over x squared minus 1. So you start by, you want to make sure if anything factors, go ahead and factor it. So I have x plus 1 over, I'm going to have, this is the differences of squares, so x minus 1 times x plus 1. Again, as you can see, they're going to factor, so we end up with 1 over x minus 1. So that means we're going to have a whole at x equals, well, when you, x equals negative 1. Let me put another step right here. So we're going to have a hold at the factor that cancel x plus 1, set it equal to 0 to solve. So when you solve it, you end up with x equals -1. We still have a denominator here. So to find vertical asymptotes, you take your denominator and you set it equal to 0. So our denominator is x minus 1, and we're going to set it equal to 0. So we end up with adding 1, so x equals 1. So we end up with a vertical asymptote at x equals 1 and a hole at x equals -1. Now your horizontal asymptote. Again, when you're doing horizontal asymptotes, you're just dealing with the degree of your top and bottom. So you look at your top. The degree on top is equal to 1. The degree on the bottom is equal to 2. So you can make the conclusion that the degree on top is actually less than the degree on the bottom. So one of the rules says when your degree on top is less than the degree on the bottom, your horizontal asymptote is the equation y equals 0. And in this case, look at the degree on top. The degree on top is not 1 more than the degree on the bottom, so you don't have to worry about any Slant asymptote. So that's how you find all three asymptotes.